Here we are on page 21 with numbers 2 through 7. Now in this case, you'll notice it says based on the figures, find the values in the similar triangles. On numbers 2, 3, and 4 first, we'll look at it. We have two big triangles here, the one ABC and then the one that goes A plus X. Let's write those down. So we've got this. This may help us to view it out here like this, A, B, and C. And since these are parallel lines, that angle and that angle are the same, and this angle are the same, and of course they share that angle up there. So it may be beneficial to write this as A plus X, and then this side over here as C plus Z, and then this bottom side as Y. That may help us out on a few of these. So let's go ahead and try them. So 2, we have A is 5, and X is 3, so we have a 5 here and a 3 there, and B is 10, and C is 7. Now if we do this, we've got 5, 10, and here we have 8. Can we find Y? Sure, we got 5 is to 10, has 8 is to Y. Obviously that was multiplied by 2 to get from 5 to 10. There's a 1/2 ratio, so Y will equal 16. Good, so we have 16. So Z, that's going to be a different one. So C up here is 7. With these parallel lines, we could do 5 is to 7 as 3 is to Z. 5 is to 7 as 3 is to Z. Now that doesn't make use of this full C plus Z over here, this 7 plus Z, but if you'd like to see it, we could also do that as 5 to 5 plus 3, or 5 plus 3 to 5 equals 7 plus Z to 7. And you could break this up into 5 over 5 plus 3 over 5 equals 7 over 7 plus Z over 7. And these 1's will subtract off when we get 3 is to 5 as Z is to 7. 3 is to 5 as Z is to 7, or do the proportions the other way around. So we're able to get this proportion through parallel lines. So we get 5Z equals 21, and divide by 5, and we get Z is 21/5 or 4.2. Okay, there was number 2. Let's try number 3. Number 3. We have A is, we don't know, okay. B is 6. Let's put that guy there. X is 4. I'm going to put this guy up here. Y is 9. And B is 6. And then Z is 5. Okay, so from the small triangle, let's put this guy down here. It's a 6 to 9 ratio. So let's do that to get X. We have 6 is to 9 as A is to A plus 4. We can solve this guy. Multiply both sides by A plus 4 and 9, and we get 6A plus 24. Some people call that cross multiplication, equals 9A. Subtract the A over here, and we get 24 equals 9A minus 6A is 3A. So A equals 8. Good. Now, if we have A is 8, 8 is to 4, as C is to 5, or we could do that the other way around. 8 is to C as 4 is to 5. Let's write that one down here. C is to 8 as 5 is to 4. C is to 8, doing this right here, and then in this parallel right down here. And we get 4C equals 40. So C has to equal a 10. Excellent. All right, let's try number 4. Number 4 we get with, we have B is 12, C is 11. Okay, so B is 12, C is 11, good. And Y is 20. So we put a 20 down here. Okay, so 12 to 20 is this ratio that we have here, that's good. And we have X as 7. Okay, so X is 7 right over here. We can put a 7 right there if we need it. All right, let's see if we can find some good ratios to help us find out what we need. So 12 is to 20 as 11 is to 11 plus z. So 12 is to 20 as 11 is to 11 plus z. So you can see that right in here. 12 is to 20, 11 is to 11 plus z. Let's multiply both sides by this 11 plus z, and the 20, cross multiply if you will. So we get 132 plus 12z equals 220. Subtract 132 and we get 12z equals 88 is what that looks like. Is that correct? So we get that z equals 88 over 12, which is the same as, let me see, if we divide top and bottom by 4, we get 22 thirds. All right, so z is 22 thirds. Now let's see if we can find a. We have, a is to 11 as 7 is to 22 thirds. Ooh, that doesn't look very nice. 22 thirds over there. We could do the same thing we did before. We could do 12 is to 20 as a is to a plus 7. Let's cross multiply and we get 12a plus 84 equals 20a. And subtract that over, we get 84 equals 8a. Divide both sides by 8 and we get 8a equals 84 divided by 8, which is 21 divided by 2. So we get 21 divided by 2. Let's try that other one to see if it would have given us something a little bit easier. 11 is to a as 22 thirds is to 7. Well, let's multiply that up there and we get 77 equals 22 thirds a. So times by 3 and divide by 22. If we take 77 times by 3, divide by 22. Let me see, we can cancel 11 out of there. We get a 2, cancel 11 out of there, and we get a 7. 7 times 3 is 21 over 2. Oh, look, we get the same answer either way. I'm not sure which one would have been easier. Okay, let's move over to the next one and do number 5. So over here, we're going to look at, so over with this one, you'll see there are 3 triangles, and it's really nice to write these out. So you can see x plus y is going to be a c and all of that. But we're going to take this triangle, this BZY, and keep this angle right here fixed and march it along and look at it like that. So this angle is the same. We're going to have a right angle here. B is the hypotenuse, so we twisted it so that y is on the bottom, AZ is still over here on the far side, and that angle stayed put right where it was. Now we're going to take this triangle up here, and notice that we've got 2 angles right up here, and I'm going to keep that one the same. I'm going to make it, it's going to be a much smaller one, but we're going to keep that one the same. Opposite of it is the Z. There's the right angle. We have the A as the hypotenuse and the X over here. We switched those we didn't switch in places. We twisted the triangle so it would be in the same orientation as the big triangle there. But here's, so you can see, we have 3 triangles that are all similar now, so we can draw these, draw the proportions that we need to. So on number 21, we have number 5, page 21, number 5. So we get that A equals 5. Okay, so let's put that one down here. Good. B is 12, so we get that guy there and there. And we don't know what C or X, Y, or Z are. Well, what are we going to do with that? Well, in this top triangle, we have a Pythagorean theorem. We can do 5 squared plus 12 squared equals C squared. And we did this before with the Pythagorean triples. This is 25 plus 144 is 169. C squared is 169. This has to be a 13. So C is 13. 5, 12, 13 triangle. Now, can we find any of these others? Yeah, because we have this full triangle up here, we only need to say, okay, we can draw it to this one. 13 is to 12 as 5 is to Z. Let's write that out. 13 is to 12 as 5 is to Z. All right, we can multiply, so we get 13Z equals 60. So Z equals 60 thirteenths. Good, let's put that up there, 60/13. Okay. Okay, now let's try getting an x or a y. Yeah, we can go 13 is to 5 as 5 is to x. 13 is to 5 as 5 is to x. If we cross multiply, we get 13x equals 25. X equals 25/13. So 25/13 is x. And then we get y. We can do 13 is to 12 as 12 is to y. 13 is to 12 as 12 is to y. Times the y up here, and we get 13y equals 144. And then y equals 144 over 13. 144 over 13. Good, so that's number 5. Those were some interesting fractions we got there. Okay, let's try number 6 now. We have a is 5. Okay, so we'll put that where he goes. Good. And x is 3. Oh, we're down here on this, so this little guy right here. Well, this has an a squared plus a b squared equals c squared. We have 3 squared plus that z squared equals 5 squared. So we get 9 from 25, z squared equals 16. Z is a 4. It's probably the only nice one we're going to get right now. So we have one complete triangle. We can now draw the proportions. 3 is to 5 as 5 is to c. Let's write that over here. 3 is to 5 as 5 is to c. Well, we get 3c equals 25, and c equals 25 thirds. Okay, 25 thirds goes right there. Okay, what else can we get here? 3 is to 5 as 4 is to b. 3 is to 5 as 4 is to b. Okay, so we got c. We're now getting b. 3b equals 20. b equals 20 thirds. Okay, that's good. And we get, yeah, b is 20 thirds. Let's put that up there, 20 thirds. So now we need to be able to get y. Let me see, we got b is 20 thirds, and we got z is 4. We could do an a squared plus a b squared equals Pythagorean theorem in here. Is there any other way to get the y out? We could do 4 is to 3 as y is to 4. Oh, that looks pretty nice. Let's try that one. So we're taking 4 is to 3 as y is to 4 and drawing that proportion. 4 is to 3 as y is to 4. And we get, just times both sides by 4, and we get 16 thirds equals y. So we get 16 thirds. Excellent. And yeah, we get a 16 thirds for y. And yeah, this is a 12 thirds, 16 thirds, 20 thirds. That was one of our Pythagorean triples, all divided by 3. Good. And now let's try number 7. This gives us an x and a y, but not the z. Ooh, so this is a 3 and a 12. This is the first one they gave us something where we don't have 2 in the same triangle. So x and y. So x is 3 and y is 12. Let's put those there. So we have to be clever with how we're going to get a variable out of this, because we know c. Oh, we know c is 15. Oh, that was good. 3 plus 12 is 15 up here. Good. Well, we can do, we don't have a complete triangle, but I want you to notice these connections here. That z is to 3 as 12 is to z. And even though there are 2 variables in that proportion, we happen to find one even though there are 2 variables in that proportion, right? 3 is to z as z is to 12. They're the same variable. We can still solve for that. So we get, multiply and multiply, we get 36 equals z squared. Z equals 6. The proportion of 3 to z is the same as z to 12. That's pretty cool. So yeah, it turns out that z is 6. Now we have some stuff. Now we can do some things. It looks like we could do it with some other ones if we needed to. We now have some options in how to get a. We could do 3 squared plus 6 squared equals a squared. Okay, so 9 plus 36 is 45 equals a squared. So a equals the square root of 45. Ooh, not even a fraction. This is, let me see, that's the square root of 9 times 5, 3 square roots of 5. So a is going to be 3 square roots of 5. But I want to draw your attention to, while we've got this problem up, that we could have also done 15 is to a as a is to 3. Can you see that? Hypotenuse to hypotenuse, short leg to short leg. So we could have done 15 is to a as a is to 3. And notice what equation we get produced here. This is 45 equals a squared. Again, a is right in the middle of 15 and 3 as a common ratio, 15 down to a down to 3, and it's square root of 45. We would have gotten the same thing. All right, b's the only one left. We could do 15 is to b as b is to 12. That's pretty cool. 15 is to b as b is to 12. So we get 180 equals b squared. So b equals square root of 180. Can we simplify that? I hope so. This is, oh, I don't know, 90 times 9 times 20. Oh, that's good. 9 times 20. And that's 4 times 5. So this is 36 times 5. Which square root of 36 is 6 square roots of 5. So b is going to be 6 square roots of 5. And does that make sense if that's 3 square roots of 5 and that's 6 square roots of 5? It does indeed. Notice that z, when we got z, was 6 and y was 12. This ratio of short leg to long leg is 1/2. And yeah, so I think that'll work. That was a 6, 1 to 2, 1 to 2. Yep, 1 to 2. B is going to be 6 square roots of 5. Notice we could have also done 6 squared plus 12 squared. Z squared plus y squared equals this b squared over here. And 36 plus 144 is 180 equals b squared. And we're in the same boat. So that's pretty neat. And this introduces the idea of a geometric mean, that these guys are actually the common ratio from 12 up to b, b up to 15, or 3 up to a up to 15. Gives us the idea of what a geometric mean is. Good.